completing the square. So here is our first example. We have x squared plus y squared plus 18x minus 22y plus 138 equals 0. And this is called the general conic form. And when you complete the square, you can get the equation of the square in standard form. And standard form is what we like because we can see what the center of the circle is, and we can see what the radius of the circle is, and we can graph it really easily. Okay? So when you're completing the square and you have x terms and y terms, the first thing you want to do is get the x's together, get the y's together, and then any number, any number that you don't have an x or y with, you want to get to the other side of the equation. So I'm going to put x squared and positive 18x right here, and then y squared minus 22y, and then I'm going to put negative 138 because I'm thinking about subtracting it over to the right side. I'm going to put that over. And then when we complete the square, if you guys remember, you have ax squared plus bx plus c. The b value is the one that comes right in front of x. So what you do is you take your b value and you divide it by 2. So I'm going to say 18 divided by 2 is 9. And then I take that number and I square it. What do I get if I do 9 squared? 81. So that 81 is the number that completes the square, and I put plus 81. And then to keep an equation balanced, if I add something to the left side, I also have to add it to the right side. So since I added 81 to the left, I have to add 81 to the right. Right? And then I'm going to do the same thing again. Negative 22 divided by 2 is negative 11. Negative 11 squared is 121. So I'm going to add 121 up here. And then since I added that to the left side of the equation, I also have to add that to the right side of the equation. So plus 121. And what I'm going to end up with is something squared plus something squared equals a number. And once I have that, I have my equation in my standard form, and it's ready to graph or find information from. Okay? So when you put this in the parentheses, you have to think about what would happen if you factored x squared plus 18x plus 81. So you'd be looking for two numbers that multiply to 81 but add to 18, and that would be 9 and 9. You'd have x plus 9, x plus 9. And instead of doing that work, you can just say whatever number I got when I divided it by 2, that's what goes in the parentheses. Okay? So I'm going to say this is x plus 9 squared. Over here, when I divided by 2, I got negative 11, and so I'm going to write y minus 11 squared. But again, if I tried to factor that, I'd be looking for two things that multiply to 121 that add to negative 22, and that would be negative 11 and negative 11. Two sets of parentheses that are identical. Okay? And then over here, we have to do negative 138 plus 81 plus 121. Anyone have that? 64? Okay. So now we have the equation. This is it written in standard form. And so what would the center of this circle be? Negative 9, positive 11. And what would the radius of this circle be? Which is 8. Yeah, the radius would be 8. So once we convert it into the standard form, it's really easy to work with. Okay? All right, let's go ahead and try another one, and this time you guys are going to help me with it. So we'll go ahead and do x squared plus y squared plus 32x minus 30y plus 477 equals 0. And what should I do first? Kind of like combine like terms, but I group them, right? Group them by the letter. So I'm going to have x squared plus 32x, y squared minus 30y, hey, will you shut the door when you come in? Thank you. All right. And what do we do? Divide by 2. Yep. So 32 divided by 2 is 16. 16 squared yeah, 256. And so we take that 256 and we add it right up here. And where else do we have to add 256? To the right, to the negative 477. So add 256, okay? And then what do we do right here? Divide by 2, so negative 30 divided by 2 is negative 15. And then we have negative 15 squared, 225. So we're going to go ahead and we'll add that up here. And then we also have to add that to the right side. So we have something squared plus something squared equals something. Okay. So what should I have in my first parentheses? Plus 16, so the number I got when I divided by 2 is what goes in those parentheses. X plus 16, what do I have over here? Y minus 15, and then what do I have here? Four. Marvelous. So the center of the circle is negative 16, positive 15, and the circle has a radius of 2. All right. I want to show you guys another type of problem. It's going to come up today, but not when you're studying circles, but we're going to do it anyway. So this one is x squared plus 4y squared minus 14x plus 32y minus 31 equals 0. Anyone see what's different about this one? The y squared has a coefficient, yeah. So it makes the problem a little bit more difficult, but not like too bad. It just adds one extra step. So we're still going to start off the same. We're still going to put all the x's together and put all the y's together. So that gives me x squared minus 14x, and then I have 4y squared plus 32y, and on the other side I have the 31. Positive because it was negative over here. And so when you move it over, it would make it positive. So on these ones, before you get started with the part where you divide by 2, you have to take that coefficient out, okay? And it doesn't matter if when you take it out, it gives you a fraction or something. It has to be completely taken out. Most of the time, it won't give you a fraction. Most of the time, it will come out clean. But it is possible that it could come out and be like some sort of fraction there. So if you take the 4 out, this one does work out nicely. That would give you y squared plus 8y. And then the x part we can leave just the same. And now we can go ahead and do the part where we divide by 2. So for this one, I'm going to say negative 14 divided by 2 is negative 7. Negative 7 squared 49. So 49 is the number that completes the square. And since I added 49 to the left side of the equation, I also have to add 49 to the right side of the equation. Okay. And then for this one, we'll do the same thing. 8 divided by 2 is 4. 4 squared is 16. And so 16 is the number that completes the square. Now here's another part that's different because we didn't just add 16. We have a 4 outside the parentheses. What do you typically do with a number outside parentheses? You distribute it, right? So what happens if that 4 got distributed to the 16? It would become 64. So I didn't really add 16 to the left side. I really added 16 4 different times. 4 times 16. That's how many times I added it. So 4 times 16 is 64. That means I have to add 64 to the right side to balance what I did. Okay? So that 4 in front of the y squared made the problem just a little bit different. So we're going to have something squared plus 4 times something squared equals a number. And what would I have in my first set of parentheses? X minus 7. What would I have in my second set of parentheses? Y plus 4. And then what would I have on the other side? 144. Okay. And this problem is not quite done, but we're going to be learning about it a little bit later, so I'm going to leave it there for now. Okay. All right. So to get started, we're going to go ahead and work on a worksheet that has to do with circles. And then partway through the period, we'll switch over and do ellipses instead. All right, so on your notes, if you want to give it a title, these are called conic sections. And a circle is a conic section, but you guys, you've seen circles in other contexts, which is why we didn't say that to begin with. But the next conic section we're going to look at is an ellipse. So if you're giving your notes a title, that's the title you would use. All right, so if you look at your packet, your resource packet, these are the different conic sections, and here's a picture so you can see what they come from. What we mean when we say conic sections is that they're coming from a cone, so you guys can see this is a cone, and the cone is like hollow on the inside. It'd be kind of like a funnel. There's just like no hole on the other end, so it's a cone. What I mean by section is it's like you took a knife and you sliced the cone, and it's kind of like saying what's the shape of the slice that you get. Okay, so if you put a slice that is perfectly perpendicular to the cone, that's how you get a perfect circle. If you get a slice and you go sideways as you go through the cone, you're going to get an ellipse. It's going to look like a circle that has been squished. So kind of like an oval is the right way to think of it. Parabolas, we've seen those, but you can get those from a cone as well, and so we would call that a conic section. And then hyperbola is kind of like getting two parts of the cone at once, and so it's like you have two different parabolas, basically. Okay, so today we're studying ellipses. Tomorrow we're going to study ellipses again, then we'll study parabolas, then hyperbolas. Okay? All right, so on your paper, we're going to go ahead and write the formal math definition of an ellipse. So if you guys recall from the video, the formal math definition of a circle is that there's a point in a plane such that all the points that are equally distant from that point, that's like how a circle is formed, right? That's the formal definition. For us, we say just like the letter O or whatever. That's what we say usually. So similar thing with an ellipse, we have an ellipse is the collection of all points in a plane. So the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. So an ellipse is the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. And that sounds like gibberish, and I'll explain it in a little bit. Okay, we're going to look at ellipses first. They're easier to work with than they sound like. I mean, they're definitely harder to work with than circles because circles are pretty easy, but they're still not bad. The definition just sounds really weird. All right. So go ahead and write the equation for the formula of a circle. So if we have x minus h squared plus y minus k squared equals r squared, the equation of an ellipse looks really, really similar to this, but you can't have it equal r squared because in an ellipse you don't have a radius. It's like the same all the way around. That would make it a circle. And so with an ellipse, they divide by the number on the end, and they make it equal 1. So this right here is still the equation of a circle. It's just an alternate form of the equation of a circle. And so when you do problems, anytime for the rest of this unit, if you do a problem and you have to come up with the equation of a circle, you can do the formula that you've been working with on the front side of the worksheet, or you can use this formula. And you'll see that both of those formulas are written on your sheet. So this is the one we've been using. This is the one you've probably seen before. This one is the one that starts to show up usually when students start to do this unit, and they get used to it because if you look at these problems, the ellipse and the hyperbola have kind of similar equations, and those equal 1. And so it will become a habit for you to make these equations equal 1. And so they say with a circle, if you make it equal 1, that's still okay. All right. So the difference between a circle and an ellipse, if you look at the equation, is that a circle has a radius that's like the same all the way around. An ellipse has 2 different values. And that's because it's like a circle that has been squished. So the amount that it goes left and right from the center might be different than the amount that goes up and down from the center. That's what makes it so you know that it's an ellipse. So if we flip back to that problem, that last completing the square problem that we were doing, that one, when you have that 4 with the y squared, that actually means that what you're working with is an ellipse, not a circle. And the reason that we know that is because the coefficients are different, and that's going to make it so that the amount you go left and right from the center and the amount you go up and down from the center are 2 different numbers, and that's what makes it so it's an ellipse. So if we look at this, when we finished this problem, what we would do is we would make it equal 1. So we would divide by 144, divide by 144, divide by 144, like that. Anyone know how many times 4 goes into 144? Nope. 36, yep. So you can go ahead and fix that. So this equation is what we would do to finish the completing the square process so that it looks like an ellipse. So you could look at it and say, oh, the center is +7, -4. It's going to go left and right 12. It's going to go up and down 6. Does it make sense how I got those numbers? Okay. So the same idea as the r squared, we just have 2 different radius squareds, basically. Okay. All right, so on our paper, we're going to go ahead and write that the center is still HK, but instead of having an R, we have an A and a B. And the A you can think of as the radius to the left and right, although radius is technically not the right word because a radius implies it's the same all the way around. But radius to the left and right is kind of like the common sense way of thinking about it. And then the B value is the radius up or down. So we're going to go ahead and sketch an ellipse. We're going to sketch x minus 2 squared over 16 plus y plus 1 squared over 9 equals 1. So the center of the ellipse would be what? 2, -1. And from that center, we're going to go left and right 4, and we're going to go up and down 3. Okay, left and right 4, up and down 3. So I'm going to go ahead and start drawing a grid on my paper that's big enough to be able to do that. And you're going to draw it too. So there's 2, -1. And from there, I'm going to go right 1, 2, 3, 4, and left 1, 2, 3, 4. And I'm going to go up 1, 2, 3, and down 1, 2, 3. Looks like I didn't really space that well. All right, so they're pretty easy to graph. Would you guys agree? You can draw them pretty easily. Okay, so if you open up your packet and look at the ellipse, the difference between an ellipse and a circle really comes down to all the different terms we have for each of the different points. So in a circle, you basically have like 2 things. You have the center and the radius, and that's like all you look for, all right? In an ellipse, we have all sorts of different points, and they all have different names, okay? So you have 2 different ways an ellipse could be oriented. This is one that kind of goes left and right. There's an ellipse that kind of goes up and down, and it depends how big the numbers are. So this one, the a squared was less than the b squared, or was more, sorry. The a squared was more than the b squared, and so that makes it so the ellipse kind of goes left and right. It's like bigger that direction, okay? And so it's oriented like this. So we have different names for these points, and depending on the orientation of the ellipse, the names kind of change. So the names are based on the picture. Whichever points are furthest between left and right, up, down, whichever points are furthest are called the vertices. So for this one, here's a vertex, here's a vertex, and then whichever ones are closer are called co-vertices. So we have a co-vertex and a co-vertex. And it is often the case that when you draw a picture of an ellipse, they want you to write down what the vertices and co-vertices are. So for the vertices, if your grid is good enough that you can tell what the coordinates of those points are, you can look there. Or we could just think about the center and think about taking the x-coordinate and going left 4 and going right 4. So if I went left 4, I'd be subtracting 4. If I went to the right 4, I'd be adding 4. So there's my vertices. My co-vertices would be if I took the center and went up 3 and down 3. So 2, negative 4 if I went down 3, 2, positive 2 if I went up 3. There's a part in the picture that is not labeled, and those are the major and the minor axis. So axis, kind of like axis of symmetry, it's the line that you could fold the ellipse in half on. So whichever line is longest is called the major axis. So the major axis is always going to connect one vertex to the other vertex. So I'm going to go ahead and label that this right here is the major axis. Whichever one is shorter is called the minor axis. And then when the orientation changes, those names change. So here, this one would be the major axis. And then this one would be the minor axis. And so oftentimes when you draw an ellipse, they'll ask you what is the major axis, what is the minor axis. Those are horizontal lines and vertical lines, and they go straight through the center of the graph, which means that those horizontal and vertical lines are going to have the same numbers that you had from the center. So for this particular graph, the major axis is horizontal, and so that's a y equals equation. And so we're going to say y equals -1 because it goes through that center. The minor axis is vertical in this problem, and so that's an x equals equation. And so x equals 2 because it goes through that center. Sometimes they'll ask you for the length of the major axis or the length of the minor axis. And so since the major axis was horizontal and we went to the left 4 and to the right 4, this one would have a length of 8. Since we went up 3 and down 3, the minor would have a length of 6. Okay, so it's pretty common for them to ask you some questions like that. And now you might be starting to see why I gave you that packet. It's not that what we're doing is difficult, it's that there's so many different words that mean all sorts of different things, and the orientation can change. It's just a lot to memorize. The length, how I got the length? Okay, so from the center, we can see that underneath the x value is a 16, and the square root of 16 is 4. So that told me to go left 4 and right 4. And since I went left 4 and right 4, I know that my length is 8. And then underneath the y is a 9, the square root of 9 is 3, so I went up 3 and down 3, and that's how I knew that was a length of 6. You would never, don't say width and height, always just say that it's the length of them, and we're going to call it major axis and minor axis. Yeah, good question. Okay. All right, so we have that, and then one last piece on here, you can see that it says focus. There's a focus here and a focus there. When you say focus plural, that's called foci or foci or foci. 3 different ways to say it. All of those are correct. A lot of people like foci because you can say, what, the foci? Get it? Okay. So the way that you calculate the focus, and you'll notice that the focus changes. So here the focus is left and right, here the focus is up and down. The focus always is on the major axis. So whatever line has your vertices, that's where your foci are going to be, or foci, or foci. And the way that you calculate it is it's a c value. You can see that right there. And to calculate c, you do a squared minus b squared or b squared minus a squared. It's just the bigger one minus the smaller one. Okay, so when you look at your ellipse, we're going to do bigger number minus smaller number. Okay, so over here I'm going to find the focus for each axis. So we have c squared. Can you leave it propped open a little bit for the other seniors? C squared is going to be 16 minus 9. And so what is c squared? 7. And so that means that c is the square root of 7. So what you'll run into as we do these problems is that typically either the c value is a square root, and so it's not a very nice number, or one of these is not a perfect square. You're not ever really going to have a problem where all the numbers are nice. Okay, somewhere in the problem you're going to have a number that's a little bit messy. Okay, so for us to draw the focus, we would have to start at the center, and we're going to go along the major axis, and so that means we're going to go to the left and to the right square root 7. Okay, so here, and this is the way you spell focus plural, so foci, 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 however you want to say it. We're going to take the x-coordinate and add square root 7 and subtract square root 7. You do not have to draw the focus if you don't want to. Okay, so I'm going to say 2 minus square root 7, comma, negative 1, and 2 plus square root 7, comma, negative 1. Okay, and that's basically what I'm going to ask you to do today. Draw the equation, find all the things, but you have these diagrams to go based off of, okay? So the problems are not necessarily hard to do, they're just kind of tedious. It's going to feel a lot like busy work, okay? All right, let's try another one. We're going to sketch x minus 5 squared over 9 plus y squared over 20 equals 1. Okay, so what would the center be for this equation? 5, 0. So 5, 0. From that center, we're going to go left and right 3, and we're going to go up and down the square root of 20, whatever that decimal happens to be. Square root of 20 is in between the square root of 16 and the square root of 25. So it's some decimal between 4 and 5, right? So when we draw this, we have to be able to go to the right 5 and draw our center, and then go left and right 3. We have to also be able to go up some decimal between 4 and 5. So let's go ahead and draw our picture. Now, one trick that you're going to realize this unit is that even if they don't ask you to draw the picture, you're going to want to draw the picture. Because as soon as you draw it, you can use your common sense to help you figure out some of the answers. If you don't draw it, your common sense will not help you. Okay? So there's the center. I'm going to go left and right 3. And then if you actually check the decimals on the square root of 20, square root 20 is a little less than 4.5. So when we graph it, we can just basically go for 4.5. So 1, 2, 3, 4.5. So for this picture, are the vertices left and right, or are they up and down? They're up and down this time. because that's the further distance. And when you do these problems, I do not want to see decimals. I always want to use the square root answer. You do not have to simplify the square root, okay? So I'm just going to say my vertices are 5, comma, and then up square root 20 and down square root 20. For the co-vertices, we went left and right 3. So what would those co-vertices be? Eight, 0, and 2, 0. So that one was pretty easy to look at the picture and tell. So the major axis is vertical. That means it's x equals comes from the center, goes straight through the center. 5, x equals 5. So here's the major axis right here. And then the minor axis is horizontal. That would be y equals 0. And what are we going to do to find the foci? C squared is a squared minus b squared, or in this case, it would be b squared minus a squared because the b squared is bigger. So we're going to say 20 minus 9. What's 20 minus 9? 11. So that means that C is square root of 11. And then, since we know that the major axis goes up and down, that means that each focus goes up and down. So we're going to start at the center and go up square root 11, and then start at the center and go down square root 11. So what would those points be? 0 plus root 11, which we could just write as root 11. And then what would the other one be? Negative root 11. Okay. And we can also say the length of each of the axes, right? So the minor axis would have what length? 6. The major axis went up square root 20 and it went down square root 20. So we would say square root 20 plus square root 20 would be 2 square root 20. Because we're adding 2 of them together. So the length of the major axis would be 2 square root 20. Okay, we're going to do one more example that is going to feel redundant, but we're going to do it anyway. Okay, so for this last example, can I take this away? I'm going to give you the equation of an ellipse in general conic form, and we're going to write it in standard conic form. So standard form is what you can look at when you can see, oh, the left and the right radius is this, and the up and down radius is this. I can see what the center is, and it equals 1. That's your standard form. The general conic form is the form that it's in before you complete the square. So I just want to make sure that we can handle that extra coefficient in there. Okay? So what you'll notice from the general conic form is if the x squared and the y squared do not have coefficients, or it's not very common, but it is possible, if the x squared and the y squared have the same coefficient. So if it said 4x squared plus 4y squared, then that would still be considered a circle. Okay? This I can tell is an ellipse because they have different numbers. This one has a coefficient of 4, the y has a coefficient of 1, and that's what's going to make it an ellipse. Okay? All right, so what do we do first to complete the square? Separate the x's and the y's. So 4x squared minus 8x, and then y squared plus 4y. It's going to equal negative 4. And then what do we do? Take care of this 4. So I'm going to take the 4 out, and that's going to give me x squared minus 2x. And then the rest of it, I'll just kind of move down. And then what do I do? Divide by 2. So I'm taking my b value and dividing by 2, and I get negative 1. And then if I square it, what do I get? 1. So 1 is the number that completes the square, but I didn't really add 1. What did I actually add? 4. So since I added 4 to the left side, I have to add 4 to the right side. And we do the process again. So here's our b value. Divide by 2. And then square it. 4. And so we add the 4 up here. And since I add 4 to the left side, what do I do to the right side? Add 4. So now I have 4 times something squared plus something squared equals a number. And what do I have in my first parentheses? X minus 1. And my second parentheses? Okay, and that equals 4. Negative 4 plus 8 is 4. Is it done? It's very close. Divide by 4 because we need this to be a 1. So divide by 4, divide by 4, divide by 4. And these 4's cancel as well, so I have x minus 1 squared plus y plus 2 squared over 4 equals 1. Now for this unit, most of us would not ever leave a 1 down there, but for this unit it's kind of nice when they do have the numbers written underneath. So if you want to put a 1 there, this is probably the one circumstance where no one's going to be like, you're silly, you wrote a whole number with a 1 underneath it. Because that 1 means something, right? What does that 1 mean? How many move to the left and right? So this ellipse is centered at positive 1, negative 2, and then it would go left and right 1 and up and down 2. Okay, so that 1 there is kind of nice to have. So if you want to write it, you can. If you don't want to write that 1, you don't have to. Okay, so that 1 right there is optional. All right.